The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, welcome to this webinar on myths of exploratory testing. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I'm the author of 12 books on software testing, including the bestseller, Managing the Testing Process, and 4 books on the ISTQB program. Attendance at today's webinar earns PMI PDUs. I would like to thank Rex Price for reviewing the materials for PDU status and making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Before we start the presentation, a couple of housekeeping notes. If you have any questions, feel free to submit them at any time via your webinar interface, but please note they are answered only at the end. You do not need to ask for presentation copies. The presentation is already posted. Go to rbcs-us.com, select the Resources tab in the upper middle. From there, navigate to the Basic Library, and voila. By attending this webinar, you are automatically registered for the free e-learning drawing. Check your email over the next couple days and watch that spam filter. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS, we are a not just for profit company. So, exploratory testing. A brief definition here is we can say that exploratory testing involves using your knowledge, experience, and skills to test software in a non-linear, unpredictable, investigatory fashion. So, one of the things that we need to do is look a little bit more closely at what exactly that means, which we will do here today. I also want to explode some myths about exploratory testing, like where it came from and what its value is and isn't, and whether it can actually be managed, and whether it's a nice to have or a must have. So without further ado, so exploratory testing. Somebody at the afternoon session today asked a perceptive question. They said, well, is exploratory testing just not scripted testing without a script? And I said, well, no, it's more than that, because just testing without a script, I mean, that would include just some, person sitting around banging away like a drunken monkey on the keyboard and seeing what happens, or maybe not paying a whole lot of attention to what happens. That's testing as practiced by some test practitioners, and certainly is not anywhere near what I would consider exploratory testing. It's more like a waste of time. Also, a lot of user acceptance testing doesn't follow a script. It's just done by the user's memory of how they use the system to do something, and I wouldn't really consider that exploratory testing either, because in that case, it's very much just focused on this narrow goal of confirming that the system works the way I expect it to work. It's mostly about confidence building. So for me, exploratory testing has a number of dimensions. One is not being scripted, but another dimension of it is this application of skills, knowledge, and experience. So a person bringing all of the relevant knowledge, potentially skills in the area of the business domain, in terms of software development, in terms of testing, their experience with things like how they've seen applications like this work and not work in the past, all of those things being brought to bear on testing. Also, in exploratory testing, the primary test basis and test oracle are your skills, experience, and knowledge. Now, by that I mean, by test basis, I mean where you're deriving your tests from, where are your testing ideas coming from. So in requirements-based testing, analytical requirements-based testing, your test basis is the requirement specification itself. But in exploratory testing, it's your skills, knowledge, and experience. You may look at a requirement specification. You may look at reference systems like legacy systems or competitor systems, but mostly you're focused on what do I think I should test? Or how do I think I should test this? Same with the test oracle. So again, going back to analytical requirements-based testing strategy, in that your primary reference to determine whether a test passed or failed, which is what your test oracle is the requirement specification. But in the case of exploratory testing, no, it's skills, knowledge, and experience. Now, any sort of technique where skills, knowledge, and experience are the primary test basis and test oracle is an experience-based testing technique. So exploratory testing is a form of experience-based testing, but it's not the only one. So for example, a checklist-based approach to testing is experience-based. If I create checklists based on what I consider to be the most important features and functions of a particular application, that's experience-based. But it's not exploratory because checklist-based test is linear. It will follow that checklist. Excuse me. Exploratory testing is nonlinear, meaning we don't follow a particular checklist. We go where the software leads us, and we investigate what the software does. How the software behaves in one circumstance informs what we should do next. So that to me is what constitutes a true exploratory test. Though there's certainly a lot of just, the drunken monkey stuff, the ad hocery, sitting and banging away, that is done in the real world and is called exploratory testing, just basically to put lipstick on a pig. Now, ISTQB did a survey not too long ago, and they found that one of the questions they asked was about which test design techniques do you use, or which test techniques do you use, and 2/3 of the test teams reported using exploratory testing. Though again, whether that's true exploratory testing per my definition or the lipstick on a pig version, that depends on who you're asking, I suppose. The only technique that scored higher than that was use cases. Now, I think actually people might have misunderstood the question to some extent, because they might have confused use cases with the similar though different concept of user stories, which are prevalent in Agile. So it might very well be that exploratory testing is the most widely used technique, though it could be that the rate of misuse exceeds the rate of proper use. I think part of the explanation for this is not so much the power of exploratory testing, though it does have considerable power, as I will note as we go forward, but also because of the absence of knowledge about other alternatives, other approaches to use. Now, exploratory testing is a kind of validation. And so in testing, we have verification and we have validation. Validation is what's happening if our primary intention of the test is measuring the software against user or customer expectations. Validation, the root there is the word value, and basically we're trying to answer the question, does the software have value? Have we built the right system? Now, of course, the issue here, the potential stumbling block, is how well does the tester actually understand user and customer expectations? Because remember, the tester's skills, experience, and knowledge are the primary test basis. So their test basis and test oracle. So to the extent that the tester properly understands the user and customer's expectations and definition of quality, they can correctly validate using exploratory testing. But if they do not properly understand that leads to some mistakes in terms of validation. And of course, nothing is perfect, right? So the tester's understanding of the user and customer's expectations and needs is going to be imperfect. It's a matter of degree. Now, verification is where you're checking to make sure that the system has been built properly according to the specifications. So in verification, we're looking at requirements, we're looking at design specifications and so forth, and our primary test basis and Oracle are those kinds of sources. Both verification and validation are important and necessary, that a good blend of both is required. And certainly some kinds of testing can be a mix of verification and validation, so I'm not trying to introduce a some sort of either or classification here. Its testing is either verification or validation. Testing includes activities which have validation elements, activities which have verification elements in various degrees. Exploratory testing is interesting in that it is almost purely validation. Though again, so is user acceptance testing, which is not a form of exploratory testing. So with all of that said, when I use the words exploratory testing, what I'm talking about is what I was just talking about for the last 5 minutes on this slide. So we'll talk more about how to use it effectively, but first I want to bust up some myths. So let's start with origin myths. Origin myths are always fun. Creation myths, where did this thing come from? So the origin myth prevalent these days of exploratory testing is that it was invented by people in the 1990s in Silicon Valley and West Coast style testing and kind of stuff you hear. That's in honor of the late great Justice Scalia, pure applesauce. It's almost certainly the case that exploratory testing was invented by the first person to write and run a program. Because think about it, at that point, you would have no idea. Like, you write the program and then you come in, well, does it work? And none of these ideas that we take for, well, professional testers take for granted now, like state transition diagrams and decision tables and all of that stuff, even boundary value analysis, had been thought out at that point, because remember, we're talking about the 1940s here. So certainly, people creating programs to do things like solve differential equations, which is one of the original uses of software, to solve differential equations for purposes of missile trajectories. The person testing that would then sit down and go, okay, I know how to solve a differential equation, so I'm going to solve some differential equations. And I'm going to choose various values to use to solve those differential equations, and then I'm going to check those against what the program gives me. Boom. There's that person's skills, experience, and knowledge, specifically knowledge of mathematics and the ability to solve differential equations, is being used to test the program. And they're picking data values based on their skills, knowledge, and experience. Boom. Exploratory testing. Now, even if I might be wrong about that, or even if I can't point to documentation to prove that hypothesis, I can point to documentation that proves that exploratory testing has been in use since the 1960s at IBM. Why? Well, first off, independent test teams are mentioned by Fred Brooks in his book, The Mythical Man Month, which he wrote in the 70s about his experiences developing software at IBM. So we know that there were independent test teams at IBM in the 1960s helping to develop programs like OS 360. Glenford Myers wrote a book in the mid-70s called The Art of Software Testing, where he described something which he called error guessing, which if you go back to The Art of Software Testing and look at it closely, you'll see, error guessing is a form of exploratory testing that is very much focused on trying to find bugs. And Myers, again, was describing behavior that went on in IBM in the 1960s. So any claim that exploratory testing was invented 30 years later in the Silicon Valley is, either wrong by 30 years or most likely wrong by 50 years. Now, another myth that exists around exploratory testing, particularly the ad hoc beat on it and see what happens approach, is the completeness myth, which is basically just play around with the software and make sure it works properly, and then we'll ship it. this is commonly related to the misconception about testing of like how hard can it be? Just just try it out, make sure it works before we ship it. So a lot of organizations that start without any sort of formal testing in their organization, anybody with knowledge of formal testing in their organization, start with these kind of misconceptions and myths. Now, eventually, the complete inadequacy of this particular approach reveals itself through a series of catastrophic or near catastrophic or at least very painful releases. So the myth is self-dispelling. In which case you might ask, well, okay, I buy that, but then why is the myth still around? Well, one of the things is that people can learn stuff and organizations can learn stuff, but people aren't always really good at learning from other people, and organizations aren't always really good at learning from other organizations. And so since there's so much fertile ground for this particular myth, and since the misunderstandings that lead to this myth are so prevalent, what happens is that every new tech company, every new IT group that gets formed means that the myth pops back up. This is especially true in that there's really not a lot of good testing education in computer science curricula still, though there are more exceptions now than there were in the 80s when I got my computer science degree, but still, most people will be able to get a computer science degree and not spend any time really studying software testing. So, hence this idea of just play around with it, make sure it works. Because that's what you do when you're studying software engineering in college. That's what I did all the time. I just played around with the software and, yeah, it seems to be okay. And I'd submit it to my professors. And, they would play around with it. They'd had some few standard tests that they'd created, but they didn't do an exhaustive job of testing either. So the whole way that software education works, software engineering education works, sort of reinforces this myth because, well, that's how I did it in college, so that's how I'm going to do it now. So let's suppose we got rid of that and that the trend towards more and more organizations teaching testing in college continues and reaches a point where everybody takes testing courses in college, which, that given the rate of progress, that'd be about 200 years from now, but let's assume it's sped up. Well, even that wouldn't fix the problem because we don't have any sort of standards or qualifications to determine what allows you to get a job in IT. We basically have the equivalent of someone like me who's sort of, has a, I understand how to read English, for example, and interpret it literally, and I'm a reasonably good arguer. So that'd be like basically like someone like me going in and saying, I'm now an attorney. Why? Well, because I know how to read English and I know how to analyze English text and I know how to argue with people. And that's basically where we are in IT right now, is that anybody who wants to can go, voila, I'm a tester, voila, I'm a software engineer, here I am, and so those folks, I certainly would be a horrible attorney. I'm sure I would make all sorts of neophyte, bonehead mistakes. And as long as we're at that same place in software engineering and in IT, just fixing the problem in the CS and the computer science programs is a necessary but not sufficient condition. Speaking of sufficiency, there's the sufficiency myth. So if the previous myth, the completeness myth, was based on, arrogance is probably too strong of a word, but hubris, I think, kind of fits. Excuse me, I'm sorry, ignorance is too strong a word, but a lack of awareness fits. The sufficiency myth is the other way around. This is based on either arrogance, which is probably too strong of a word, or hubris, which I think fits, which is, the myth is, oh, we've been trained by this mighty Jedi of exploratory testing, and I've got the certificate hanging on my wall that proves that I've sat in the presence of this mighty Jedi, and therefore I can find every bug that matters. reality here. Microsoft did some studies on this. Now, a caveat. I mean, I've lit into Microsoft regularly on social media for their lack of quality and their testing lapses and so forth. But I do acknowledge that they are a serious organization, and they have people in there that are doing serious work. So they did some studies, and I was made aware of these studies by a fellow named B.J. Rowlinson at a conference in Frankfurt. I don't know if he's still at Microsoft. He might well be, but he was at that time. And in these studies, they looked at the set of bugs found by exploratory testing and other kind of reactive testing strategies versus the set of bugs that were found by other testing strategies like analytical requirements-based testing strategies. And what they found is that those two sets are different and only partially overlapping. So you could be Lord King God of exploratory testing. The veritable Luke Skywalker, or Anakin Skywalker if you prefer, of exploratory testing, and that's still not going to work, because even if you find every bug that exploratory testing can find, exploratory testing can't find every kind of bug. So what you want to do instead is set up a process that includes different testing strategies at different points in the testing process and in the software development process to try to maximize the defect detection effectiveness, just like you would build a water purification system through multiple stages of filtration. Now, even so, it's important to say that if you define sufficiency of testing as 100% defect detection effectiveness, you're dead. You're doomed. You will fail. You're guaranteed to fail. No testing strategy or set of testing strategies will get you to 100% defect detection effectiveness. But you can, through careful application of quality and testing best practices throughout the life cycle, get to 99.5% or above. I've seen clients that have done that. It's just you have to remember that once you get to 99%, every additional decimal point of percentage effectiveness comes at a very high price, and it goes up as the number of zeros after the decimal point increases. So you have to balance what the appropriate target is. Now, the flip side of the sufficiency myth, which is all we need is exploratory testing, is the irrelevance myth, which is we don't need no stinking exploratory testing because we have TDD and ATDD and BDDD and whatever else, all the other DDD or DDs and alphabet soups and stuff that get promoted out there. And since we have these things, we have 100% confidence in our software. I'm making mock of this, obviously, but there are statements not terribly far removed from what I just said that can be found out there in some of the discussions specifically about TDD. So I don't think I'm too far from the mark. This is a parody based on truth. Well, test-driven development, acceptance test-driven development, and behavior-driven development are all forms of verification. They are based on the user stories and the acceptance criteria. In the case of ATDD and BDD. In the case of TDD, basically what the tests themselves are a form of executable design specifications. They express what the design is of the software according to the programmer who wrote it, either the test being written either before the code was written or immediately after, but either way, they are an expression of what the developer intended the code to do. That's pure verification, and you can't rely on verification alone because there is no such thing as a perfect set of specifications. All human work products are flawed. That's just the way they are. So don't fall for the irrelevance myth. Yes, these verification types of tests like TDD, ATDD, and BDD are important, but you also need to have the validation types of tests. So, if you're in Agile, think of the test quadrants and a proper balanced use of the test quadrants. If you're not working in Agile, think of the different test types and test levels that were discussed in the ISTQB Foundation syllabus. You want to have a good mix of all of these different types of testing. Now, the irrelevance myth is we don't need to do that. The unmanageable myth is every time we try to do that, it turns into a tar pit. And it's this complete unmanageable morass, and otherwise productive person hours of time fall into it with nothing to show for it. We don't know how to manage the work. We don't know what got done. It's just, evaporating productivity. So there are ways to capture the test coverage, and there are ways to manage it. I'm going to talk about managing it a little bit later, but in terms of capturing the test coverage, what you need here are logging tools. There's a tool out there called either Rapid Reporting or Rapid Reporter. I can't remember the exact name, but I don't remember anything anymore because the internet remembers everything for me, so I just do web searches. But the logging tools like that can, in real time, capture what you covered and what you found and what needs to be done next and so forth. And you're basically retroactively capturing the information that in the case of a pre-designed test you're trying to put in place before. And so either way, it's equally auditable. And traceability can be captured, and so it's it's a perfectly acceptable way of capturing the coverage. Now, in terms of the management, and again, I'm going to get into this one. Excuse me, just had a sneeze there. I'm going to get into this in a little more detail in a minute, but if we have a well-defined scope of testing using a test charter, which defines the test conditions we want to cover, and we set aside a particular period of time, a well-defined period of time, anywhere from 30 minutes to 2 hours, we can make sure that we are able to actually manage the testing to be done. All right, so with myths thereby busted, let's talk about how to do it. So, as I said, you're never going to have a perfect set of requirement specifications, and validation or verification by itself is never going to be enough. So you're always going to want to use certain kinds of reactive testing strategies. So reactive testing strategies are just strategies where we react to the system actually presented to us, usually using some sort of experience-based testing, including exploratory testing. Certainly in Agile, you're not going to get really good, thorough documentation many times. There's going to be a lot of change, so your reliance on reactive strategies might increase even more. But again, don't rely entirely on this. Blend the reactive testing with the other strategies, as I've said. Things like risk-based testing, analytical requirements-based testing, regression-averse testing that involves a lot of automated regression tests at various levels, maybe model-based testing for things like performance and reliability. So put those all together and come up with your perfect testing cocktail, if you will. Now, for the exploratory testing, what we're going to want to do is define the test conditions through some analysis. Analysis of what? Well, any sort of input, because remember, skills, experience, and knowledge, that's your test basis. So you're going to identify your test conditions, which are just what you want to test. You go, okay, I'm going to divide these up across a set of test charters, and test charters are just a set of test conditions that will be tested during a particular test session, anywhere from 30 minutes to 2 hours long. And those get handed out to the testers, and the testers, based on their test charter, will design and execute their tests once the software is delivered to them, and hopefully use a tool to log their results, as we discussed before. The test can indeed be designed using formal test design techniques. So there's nothing about exploratory testing that says you can't use a formal technique like pairwise testing or state-based testing. It just says that you should be using those design techniques in real time rather than trying to use them in advance. Now, the time boxing and the chartering is going to allow you to manage the testing. This is how you dispel the myth of the unmanageable process, because If we have clearly defined test charters with clearly defined test conditions and we hand those out across multiple people, we can make sure they're not stepping on each other's toes and overlapping each other's work. When we have time boxes, we can prevent a tester from going off and hamster wheeling him or herself on some sort of pointless chase after a bright, shiny object. People need to understand that the session time is the entire session time. This is the time that you have, and the expectation is that that will be measured so that there's some accountability here. People should also understand that the testing session needs to include both breadth and depth, and you need to be thinking about the level of risk before you go deep, because again, are you just chasing the bright shiny object, or is this actually a high risk area that deserves a lot of attention? Now, the charter needs to specify at the very least the test conditions to be addressed and the amount of time allowed to do it. Now, you can also list the actor. You can say here's the intended user of this particular functionality to help the tester kind of channel the user as he or she is running the test. If there are some very specific preconditions that need to be met or some test data that needs to be loaded, you can list that in the charter. You can have prioritization, which certainly if there are more charters than there is really time to run the charters would make sense, so that you make sure that the most important stuff gets run first. You can also mention what the test basis and test oracles are, though again, this is getting you into dangerous territory, because you're starting to potentially supplant the tester's knowledge, skills, and experience. If you get prescriptive in this area, you can make suggestions, but you probably want to try to leave it up to them as to what specifically they want to derive their tests from and how they want to design the tests. And same with things like activities and variations. You might want to put some, important stuff not to forget. Kind of like when you have a guidebook or a tour book, it lists like sites not to miss. But you want to avoid getting too specific in these, over documenting the charters. Now, as a tester doing exploratory testing, since you don't have the guidance of the written test, you're going to need to keep in mind some important questions while you're running your test, because again, the results of the tests as you run it are going to determine what you do next. And if you're not focusing on the important things, you're going to go the wrong way. You're going to go astray. If you're not considering what kind of failures might occur, you're going to miss important bugs. Kind of what if stuff is important, though. Again, here, the what if stuff has to be balanced against the matter of importance, because there's a risk of the bright shiny object here. Again, channeling the customer or user. What would it mean for this thing to work properly? And installation, upgrades, and uninstalls. This is something that's really important, and I think actually deserves its own separate set of charters. There are a whole lot of different installation, upgrade, and uninstall scenarios possible, and they almost never get properly tested. In fact, I wasted a goodly portion of my afternoon arm wrestling, first with AT&T, and then with some, I'm sorry to say this, that there's just completely worthless Microsoft support people that sent me bouncing around from pillar to post, not offering me the slightest bit of useful information about how to solve my problem, because my phone self-upgraded itself in spite of me telling it twice, please don't install an upgrade. It did it anyway, and blew out half of my contact information. Now, I think there's a place for scripted tests in this area, but there's also a real value of doing exploratory tests, because there's just so many possibilities in terms of upgrade paths. So, that's something important to keep in mind. Heuristics can be helpful here too. So, looking at boundaries, looking at things like if you're testing something that's got an underlying database, the CRUD acronym, create, read, update, delete. Have you tried all those different possible variations there? different ways that systems can be configured, especially with mobile devices, and possible interruptions, again, especially with mobile devices. These are all, fertile ground for things to try. And they're things that are difficult to capture in a scripted test. And this is something to keep in mind. I'm going to give you an example of a charter here that really, is, I think, a really good example of the kind of test that would be exceptionally difficult to do in a scripted way, but is actually really easy and just natural fit to an exploratory test. This is based on a real story, as most of my examples and exercises and so forth are in my webinars and courses and so forth. A number of years ago, I was managing a test team, and we had to test kind of the precursors to a sort of tablet netbook kind of system. It was a very simple, stripped-down PC that allowed you to do things like browse the web and send and receive email. Referred to at that time as an internet appliance. And it had 4 possible configurations: kids, teens, adults, and seniors. And for kids and teens, there was supposed to be filtering. Now, the filtering was supposed to prevent access to pornographic, objectionable, lewd, obscene, and violent sites. This is something that's almost impossible to script. The internet is a multi-dimensionally squirming object that changes all the time, and there would be simply no way of creating an effective and efficient scripted test for this, at least not one that ran manually. You can imagine if you had exceptionally fast internet access speeds, creating some kind of automated test that used a dictionary to generate all sorts of different possible combinations, but then where's your oracle, right? Because the computer, this is the whole problem with filtering software, and filtering software tries to automate the judgment of what's objectionable, pornographic, etc. Ain't so easy to do. So we found all sorts of bugs in this software, and finally I had this brainstorm. We've been using some kind of semi-scripted approaches up to that point, and I finally said, you know what, we're gonna have a little exploratory testing bake-off here. So I got all my testers together in a room. We had 10 testers, and I said, look, if you're easily offended, or if the words hostile work environment have ever occurred to you, take the rest of the day off on me, paid day. Just go away. You'll be glad later that you weren't here today. And everyone was intrigued, so they didn't leave the room. Everybody stuck around, and I said, okay, for those of you who choose to stay, here's what we're going to do. We are going to demonstrate what the problems are with the filtering software on this device, because we've been reporting them, and people have been going, yeah, but then nothing had gotten fixed. So I said, here are the rules of the game. Each of you is to come up with a top 10 list of nasty websites that you can get to with a kids or teen system. No fair duplication. The first one to a particular site uses that site. You guys figure out how you're going to split your work up so that you're not stepping all over each other's feet. You go after this thing. And you have from now until lunchtime. And after lunch, I'm going to bring the marketing folks up here. I'm going to show the marketing folks what we're talking about when we file bug reports, like kids and teen systems allow access to pornographic and objectionable websites. After lunch was deliberately chosen because I wanted to basically nauseate the hell out of the marketing people. So then they walked right into the trap. I went down to the marketing folks. I said, hey, we'd like to give you a little show and tell this afternoon. We're creating some examples of some problems that we're kind of concerned about and we think you should be aware of. And could you come up after lunch at, say, 2 o'clock and take a look at what we're finding? And the marketing guys were like, oh, yeah. So there were 3 of them, one man and 2 women. One of the women had young children in an 8-9-year-old kind of age range. We really target audience for this device, or one of the target audiences for this device. So it was perfect. So anyway, after lunch, they come up there, and they all come in with that kind of, full and happy look on their face that you have after you've had a good lunch. And I promptly ripped that full and happy look off their face through the demonstration of the kinds of problems that we were having. So they had 10 testers, and each had a top 10 list. So it was like 100, visions of horribleness. Imagine walking in and seeing a kid looking at that. And it was exceptionally effective. The bugs, which had been sort of relegated to non-person status for weeks, suddenly got fixed within a matter of a few days. So I bring this up for a couple reasons. One is I think it's kind of a funny story, and I hope you do too. But another is that this is the kind of thing that would have been impossible to accomplish without exploratory testing. It's exploratory testing at its most powerful. It allowed us to demonstrate a lot of problems, to come up with specific examples of problems, to do so in a very efficient and effective way, and it effected change. Those problems actually, when surfaced, resulted in fixes to the product. Notice there was no verification about this. So sometimes people say, well, if I can't point to a specific requirement and say, look, this requirement is broken, I won't be able to get anybody to fix anything, therefore I might as well not do any of this exploratory testing because it's pointless. Well, not necessarily, because sometimes, you don't need a requirement to say that something's wrong. You don't need a requirement written down anywhere to say that the system shouldn't crash and delete customer data, for example. You don't need a requirement to say that a system that's going to be delivered to kids that's supposed to have filtering in it shouldn't allow them to access porn. So an example of productive use of this. So to conclude, as I said before, exploratory testing, not a recent innovation, and certainly not an innovation created by some of the people who claim to be the innovators of it. It is almost certainly something that goes back to the first programmer. If not, it is something that goes back to a small team of programmers at IBM whose work gave us the art of software testing, for which we should all be eternally grateful. We've explored a number of myths about exploratory testing, and I hope that I've been able to burst some of those and give you a better awareness of the realities of exploratory testing, which will allow you to be more effective and efficient and smart in terms of how you put this proven best practice to work, in combination with a number of other testing strategies. It is manageable, as I've explained. You can use time boxes, charters, and logging tools to make it manageable and produce traceable results. And it is able to find certain bugs that you will otherwise not find, as the filtering example I hope made clear in a amusing and memorable fashion. So that said, let me put the ad up and we will go to Q&A. Sabian asks, hello Rex, do you recommend having exploratory testing during any test cycle, as going through the requirement may not be sufficient? Thank you. Yes, absolutely, Sabian. That question came up in the afternoon session as well, of where to integrate this. And I would say, this should really be throughout your testing. Some people relegate it to the end of a cycle of testing. Some people say no, it belongs at the beginning, but I think that since it's testing that is informed by what you have learned so far, it really ought to be integrated into all of the testing. The beginning of a cycle of testing, you've not learned a whole lot yet, and at the end of a cycle of testing, you might have missed some very important things, and which you then discover too late to do anything about with your exploratory testing. So I would say integrate it throughout. Donald, a frequent listener, and good to see you back, Donald. Could another cause of the completeness myth be a lack of time to test before a fixed release date? Sure. I mean, I think both the completeness myth and the sufficiency myth, while they are based on different things, one being based on ignorance and the other being based on arrogance, can both be driven, can be motivated by a perception of pressure, right? Well, we just got to be done, and so we're going to get it done, and then there's this, oh, that was enough, and it's enough because it's so easy, or it's enough because I am a mighty Jedi of exploratory testing, right? But yes, certainly that intense time pressure is one of the major roots of software engineering evil. I won't say root of all evil, but it is definitely one of the major roots of software engineering evil. And in fact, in a webinar coming up either next month or the month after, I forget, I think it might be the month after, doing it's called Why Does Software Quality Still Suck? This is one of the things that I actually point to, which is that this intense time pressure for getting a release out the door is behind a lot of the sort of cascading screw-ups that follow. Robin, again, very, very frequent webinar attendee, as well as an all-around good guy and personal friend of mine, says, what's your current recommendation for the percentage of testing time that should be allocated for exploratory testing, especially in an Agile environment? So for a number of years, Robin, I've said that my rule of thumb is about 20% of test execution effort ought to be allocated to exploratory testing. Now, that's assuming a relatively low rate of automation, test automation success, either because you're just getting started with the app or because test automation hasn't worked out for one of the myriad reasons that it might not. And so you're having to do a lot of manual scripted testing that includes regression testing. To the extent that you are able to successfully use techniques like, since you're talking about Agile, like TDD, BDD, or ATDD to get a lot of the testing automated, testing that would otherwise be done in a manual scripted fashion, I think that the percentage of exploratory testing should go up in those certain situations. So I would say that if you are able to automate a large percentage of your regression tests, you should look at to what extent are those basically replacing what would otherwise be manual scripted tests, and how should we revisit that 20% rule? Time box chartered test sessions is interesting, says Atsushi, and Atsushi, good to see you again. Nagata-san, hope all is well in Japan. He goes on to ask, how long is better as a time box? It would depend on the type of testing or objectives. 15 minutes. The usual rule is anywhere from 30 to 120 minutes, but I think you're right in the sense of the test conditions that you're going to cover are a powerful influence of that. And of course, the level of risk associated with those test conditions is also a powerful influence. I would say, though, that there is some cognitive psychology work that shows that after about 90 to 120 minutes, people's brains start to kind of fry a little bit, and they sort of need a break. So it's probably a good idea that if you have an exploratory testing session that is going to last longer than a couple hours, that you look for ways to break that down into logical sub pieces and define those instead as your sessions, so that you don't push people into this zone of burnout. Excuse me. James asks, and again, another longtime listener. Good to see you, James. Do you have any recommendation on how much or what kind of formal testing experience a person has before they try exploratory testing? Well, I mean, that's kind of, you're kind of asking me a question that my answer is pretty predictable there. Yes, I want, in a perfect world, if it were up to me, every tester who was able and allowed to call himself or herself a professional tester would know black box test design techniques like state transition diagrams, decision tables, pairwise testing, domain analysis, equivalence partitioning, use case-based testing, et cetera, basically all the stuff that's discussed at the Foundation and Advanced Test Analyst course, plus the kind of defect-based and experience-based techniques that are discussed in the Advanced Test Analyst course, plus the white box techniques that are discussed in the Foundation and the Advanced Technical Test Analyst courses. What's code coverage and so forth. I mean, in that world, that's the level of knowledge that people would have, and I would like to see a higher level in general of technical sophistication amongst testers. So understanding of programming languages and scripting languages, and how software is actually built. For the reasons that were discussed in the classic treatise on software engineering, Terminator 2, where the Terminator explained that he had detailed files on human anatomy to make him a more efficient killer. Same thing why people should testers should understand the internal workings of software, because it will make them more capable of understanding where the bugs are. Now, I understand that I don't live in that world. We don't live in that world. We're a long way away from that world. I'm trying to budge the needle in the direction of that world through various kinds of activities, ISTQB work, and these kind of webinars. So I guess the answer, as a practical answer, James, I guess what I would say is as much as you could possibly get. I don't think that you can take a green, unexperienced person and just throw that person in the briar patch and say, start exploring the software and see what happens. I think that's a recipe for a huge number of false positives and false negatives. And I say that not just as a matter of personal belief, but as a matter of having seen that kind of nonsense perpetrated by various organizations, including a not small number of outsourced testing service providers, with precisely that result. So, exploratory testing is an experience-based technique, and so obviously the more experience, the more relevant experience and knowledge and skill you have in terms of things like the business domain, testing, and software engineering, the more effective you're going to be. And contrary-wise, the less such skills, experience, and knowledge you have, the less effective and efficient you will be. Denise asks a question here, and Denise, again, long-time listener, good to see you again. Expected results versus actual results when writing up a bug found during exploratory testing. Great question, see, because this gets us back to you are the test oracle. So where'd you come up with your expected results? Well, you better be ready to make a case for this is why what I expect is more closely aligned with what the user values, what the customer values, than what the developer built, because otherwise you will indeed get exactly what you're pointing at here, Denise. It's just it works as designed. So, in a case like the filtering software, it was a slam dunk, right? I mean, I was just able to go, look, this thing's configured as a kid's box, and there's a picture of somebody getting dismembered, or there's a picture of some sort of very interesting sexual activity, which all more power to them, but that's something for adults, not kids. So the oracle there in that case was just common sense, right? But the further you get away from that kind of stuff, behavior that is self-evidently wrong, the more you're going to need to be ready to make that argument of why your oracle, the one inside your head, trumps the developer's oracle. And that's where the skills, experience, and knowledge comes in. Rajesh asks, are there any metrics which can be derived for exploratory testing? Sure, absolutely. I mean, if you are using the kind of logging and management techniques that I discussed, there's no reason why your exploratory tests and their results can't go into a test management system like ALM or any of the other 3 or 4 dozen test management systems that are out there, and you can report metrics from them just as if they were test cases, which of course they actually are just test cases. They just are test cases that happen to not have been written down prior to being executed. Donald asks, and this is kind of a related question, how can exploratory testing be reliably repeated or leveraged for regression sessions? This is a constant problem I see with much initial testing being reactive. Then the scope of regression coverage becomes inconsistent with no satisfactory way to demonstrate that a release is ready or risky. So this is where your tools, logging tools like that Rapid Reporter and so forth come in, because you're able to actually show, look, this is what we tested the first time around. And, conceivably what you can do if you have a good automation program in place is that those logs can be handed over to the people in charge of creating the regression test suite, and with some guidance given about, these are the tests that we think we recommend to automate, and thus those can be automated. So yeah, it's a solved problem, Donald, but it's interesting when I say solved. When people hear people use the phrase solved problem, they sometimes think non-problem, and that's actually not what I mean anyway by solved problem. It might be what other people mean by solved problem, but a solved problem to me is a problem for which a proven best practice exists. Whether that proven best practice is in practice in most organizations is a different question. Now, a lot of times people will say, well, if it's not in practice in a lot of different organizations, well, maybe it's not a best practice. Well, no, I mean, I think, because again, forward referencing that webinar that I'm going to do a little later this year about why does software quality still suck, we software profession in general and the surrounding business infrastructure around it do a tremendous amount of damage to our own ability to create good software. We put constraints around ourselves, we shoot ourselves in the foot, we do all sorts of things that are just very much bad ideas. So just because there is a known proven best practice out there does not by any means mean that a lot of people are doing it. But nevertheless, it is a solved problem, and the path is there for those who have the wisdom to follow the path. And wisdom at this point, that in this regard means not only their own wisdom, but also the wisdom of their managers. All right. Well, as always, a fascinating set of questions from my exceptionally brilliant audience. Thank you all. To close the session, a little bit more about the resources available through RBCS. You know about these free webinars. I think most of you guys are repeat attendees. So we've got our whole schedule out for the year, and I'm looking forward to doing them. So please sign up on rbcs-us.com. And if you want a special webinar presentation for either this webinar or any other software-related topic for your company, send us an email, info@rbcs-us.com. rbcs-us.com is also where you can find our free newsletter, which comes out every other month. If you sign up for that, you'll get featured articles on software testing and quality and news about what we and our partners are up to, as well as some nice discounts on our services. As you can see, I'm out on Twitter and Facebook. RBCS and RBCS Inc. are the corporate pages. Like a Test Dog, I'll have to warn you, is more personal page, and given some of the insanity that's going on in the United States politics right now, there might be a little bit more politics than you want to dip your toe into there at Like a Test Dog. But that's you just have to take that as a given if you go out there to that one. Recorded webinars on the digital library on our website. They're also on the YouTube channel, and podcasts, audio podcasts of these webinars, and are out on either on iTunes or on the RSS feed on our website. So all sorts of free stuff out there. As to paraphrase the Virgin Atlantic advertisement, take us for everything we've got. We offer these free resources as a service to the software testing community because at RBCS we are a not just for profit company. This concludes the webinar. Thanks for joining us today, and have a great rest of the week.